Imagine for a second that you are standing in the middle of this just vast, unforgiving landscape,
Yeah, totally exposed.
right? The sun is absolutely relentless, just baking the earth right beneath your feet. And the rainfall here is, I mean, it's basically a statistical error compared to what you actually need to keep your crops alive.
It's essentially non-existent when you need it most.
Exactly. So in a place like this, your daily survival, the economic engine of your entire country, and even your geopolitical stability, they all depend on this one impossibly high stakes task, which is wrangling a really fragile, highly volatile web of water.
And it is, I mean, it's the ultimate tightrope walk. Every single drop has a job to do.
Yeah.
The moment a society loses its grip on that water, whether it's, letting it evaporate or letting it flood or even letting a neighbor control it, the entire foundation of that society just starts to crack.
Okay, let's unpack this.
Mm.
Because today, for this deep dive, we are looking into the geography, the history, and the incredibly complex water management systems of Pakistan.
Which is such a fascinating case study.
It really is. And the mission for this deep dive, based on this fascinating collection of educational lectures we're sourcing from, is to really map out this delicate, high-stakes dance.
Right, because we are looking at everything from brilliant ancient engineering that kept civilizations alive in the desert to these modern mega plumbing projects that literally redrew the map.
Oh, yeah. And maybe most importantly, the bizarre environmental disasters that just inevitably pop up when we try to outsmart nature.
They always do.
Because before you can even think about managing water on like a national grid, you have to figure out how to pull it out of a landscape that is doing everything in its power to keep it from you.
Right, which requires an immense amount of historical ingenuity. I
Yeah.
mean, the natural rainfall across much of Pakistan is just fundamentally incompatible with the scale of agriculture they actually need.
Yeah, they've always had to rely on artificial supply, right?
Exactly. And if you look back at the traditional methods, it's a masterclass in pragmatic mechanics.
Pragmatic, sure, but also incredibly labor intensive. I mean, you look at something like the Shadoof from the sources,
Yeah, the Shadoof, yeah.
it's basically a giant heavy-duty seesaw built over a river or a lake. You have this pole, right, with a heavy counterweight on one end and an empty bucket on the other.
Just pure leverage.
Right. A farmer physically pulls the bucket down into the water, and the counterweight does the heavy lifting to bring it back up. It's brilliant, but exhausting.
And then you have the Persian wheel, which sort of scales that up using animal power.
Oh, right, with the blindfolded animal.
Yeah. You blindfold a camel or an ox, and you have it walk in a continuous circle to turn a series of wooden gears.
Which is just wild to picture.
It is. And that motion drives a vertical wheel that constantly dips a chain of pots down into a well. It's a beautifully simple translation of kinetic energy into water extraction.
But the limitation is pretty obvious, right? I mean, you are fighting evaporation every single step of the way.
Oh, absolutely. If you are operating a Persian wheel in the blazing heat, a significant percentage of that water is just lost to the atmosphere before it ever touches a plant root.
Which brings us to the Karas system. And this is where the engineering gets genuinely mind-blowing for me.
Khares is amazing.
Right. It's specifically utilized in Balochistan, which is this incredibly rugged, arid province. The terrain there is just brutal.
It's incredibly harsh.
Yeah, so if you try to run a normal surface canal there, the sun will just steal the water immediately. So what do? They just sidestep the sun entirely and build what is essentially an underground thermos.
That is the perfect way to describe it. An underground thermos, they tap into the groundwater right at the base of the mountains, the alluvial fans, and they dig a network of horizontal tunnels with a very, very gentle gradient.
So the water just flows downhill on its own.
Exactly. Entirely underground, completely shielded from solar evaporation.
And the detail that I found so clever about this, the part that really got me, is how they handle the maintenance shafts.
Right, because they have to get down there to clean them out.
Exactly. They dig these vertical shafts down into the tunnels to clear out the silt, but they don't just leave them open to the air, they cover them with heavy lids.
Which is crucial.
Yeah. They only pop the lids open when it rains to catch the surface runoff, and then they seal them right back shut. It preserves the ambient temperature of the water, it keeps all the dirt out, and it reliably delivers cold water to thirsty crops like dates.
It's just working completely in harmony with a hostile biome, working with the environment rather than against it.
Right.
But, that harmonious balance, it didn't really survive the modern era The population boomed, the agricultural demands just skyrocketed, and the Kerez was largely eclipsed by the modern tube rail.
Which is a huge shift.
It is. We essentially traded sustainable ingenuity for just pure brute force.
Right. Because the tube well isn't working with the landscape at all. It's dropping a motorized suction pump, like 90 meters deep,
Hmm.
and running it on a diesel generator or grid electricity.
Yeah, just straight down into the aquifer.
And I get the appeal, you know. You get massive volumes of clean water drastically faster with zero blindfolded camels required.
Which is a plus for the modern farmer.
But if the Kerez is like a carefully managed underground thermos, aren't these massive tube wells just sticking a giant industrial straw in and draining the thermos dry?
They absolutely are. Tube wells completely decouple water extraction from the natural replenishment cycle.
Wow.
Yeah, I mean, a Kerez only gives you what gravity and the natural water cable actually allow. A motorized tube well forces the issue.
It just takes whatever it wants.
Right. If you have thousands of farmers all running diesel pumps, pumping groundwater out faster than meager rainfall can recharge it, the water table just plummets.
Which is terrifying.
It is. Eventually, your 90-meter straw is just sucking air.
Which is an absolute existential terror for a farmer. Now, pulling water from the ground is one thing, but if you really want to power an entire nation's agricultural sector, you have to harness the major rivers.
You have to scale up.
Exactly. But here is the ultimate geopolitical nightmare. What happens when the rivers you rely on originate in a country you are actively hostile with?
Yeah, you were talking about the crisis of 1947.
Right.
When British India was partitioned, creating the independent nations of India and Pakistan, the borderline was drawn straight through the Indus River basin.
Just right down the middle.
Right down the middle. So the headwaters, the actual origins of the major rivers, ended up on the Indian side of the border.
Oh, wow.
Yeah. So Pakistan, a country whose entire economic survival depended on downstream agriculture, suddenly found its water supply controlled by a rival state.
And it wasn't just a theoretical fear either. I mean,
Yeah.
almost immediately after partition, India actually shut off the water flow into Pakistan's canals.
They literally turned off the tap.
They turned off the tap on a newly born nation.
It was a complete weaponization of geography. And it forced international intervention because, you had two states heading toward a potentially devastating conflict over just basic hydrology.
Which led to the UN and the World Bank stepping in.
Yes, leading to a massive, years-long negotiation that resulted in the 1960 Indus Water Treaty. They effectively drew a brand new map for the water.
Right.
Pakistan was granted exclusive rights to the three western rivers, which are the Indus, the Jhelum, and the Chenab. And India was given the rights to the three eastern rivers.
Okay, here's where it gets really interesting. Because dividing the rivers on paper is great for a treaty, but it completely broke Pakistan's physical reality.
It really did.
Their most fertile agricultural heartland was located in the east, and it was heavily reliant on those eastern rivers that they just legally lost access to.
Right, they gave away the water that fed their best land.
Exactly. So to make this treaty actually function without starving millions of people, they had to physically move the water from the west to the east.
Just an enormous undertaking.
And the international community, Western countries, the World Bank, and even India, they actually helped foot the bill for one of the largest mega plumbing projects in human history.
The scale of the infrastructure built under the Indus Basin Project is just staggering. We are talking about Earth moving on a planetary scale.
It's hard to even picture it.
It is. They built 2 massive dams, 5 barrages, and 8 major link canals.
Mm-hmm.
But to really grasp how this reshaped the country, we have to clarify the specific engineering roles of these structures.
Yeah, let's break that down.
Because they aren't just interchangeable concrete walls,
Right, because if we look at the dams, specifically the Mangla Dam on the Jhelum and the Tarbela Dam on the Indus, these are built way up in the northern mountains.
Correct.
And from the lectures, it seems like they act kind of like a national savings account. They have these towering walls designed to hold back and store immense volumes of water during the wet season.
Exactly. It's all about long-term storage.
Right. And because they are perched up high in the mountains, they can use that massive vertical drop to spin turbines and generate massive amounts of hydroelectric power for the national grid.
So they serve 2 critical purposes.
Yeah, dams store water and make electricity.
Yeah.
But barrages serve a totally different function down in the flatlands, right?
If dams are the savings account, barrages are the checking account.
Oh, I like that.
Yeah, they are built on flat terrain right across the width of the river. They don't have deep reservoirs, and they don't store water for the dry season.
So what do they actually do?
They're essentially a series of massive gates that just control the elevation and the diversion of the daily flow. A barrage takes the water coming down the river and actively distributes it into the canal network.
And that leads directly into those 8 link canals we mentioned, which were really the true lifesavers of the 1960 treaty.
Absolutely.
Because a link canal isn't just delivering water to a local farm, right? It is designed to move water laterally across the entire country.
They act as massive artificial arteries.
Right. Taking the surplus water from the western rivers that Pakistan now legally owned and transporting it horizontally to replenish the dried up eastern rivers.
They completely replumbed the hydrology of a nation. I mean, they successfully engineered their way out of what could have been a geopolitical death sentence.
Which is incredible, but of course, whenever human beings attempt to outsmart nature on a continental scale, nature tends to push back with a vengeance.
It always finds a way.
Always. So we've essentially built this massive artificial circulatory system for the country. But when you force water to flow 365 days a year through dirt canals that were never, ever meant to hold it constantly, you fundamentally break the local water table.
It's the classic environmental boomerang.
Yeah.
See, before all this mega infrastructure, they relied on what are called inundation canals, which only flowed during the natural flood seasons.
So the land actually had time to dry out in between?
Exactly. The land could breathe.
Yeah.
But the new dams allowed for perennial canals. These are canals that run continuously all year long. And because these thousands of miles of canals were largely unlined, meaning they were just carved into the raw earth, not sealed with concrete, they leaked constantly.
And it doesn't just raise the water table a few inches, right?
No, not at all.
All that continuous seepage acts like a slow-motion flood from underneath. The water table rises higher and higher until it literally breaches the surface. The farmland turns into a swamp.
Which causes waterlogging.
Right. You are in a desperate, arid climate, and you are somehow drowning your own plant roots because there is no oxygen left in the saturated soil.
And the tragedy really compounds when you factor in the climate itself. Once that water sits stagnant on the surface, the scorching sun just goes to work.
It just bakes it.
Yeah, it evaporates the surface water. But river water and groundwater naturally contain trace amounts of dissolved minerals and salts.
Oh, no. So when the water leaves...
When the H2O evaporates into the atmosphere, the salt stays behind. Over years of this continuous cycle, capillary action draws more and more salt up to the surface, leaving behind this thick, toxic, snow-white crust across all the fields.
Salinity.
Salinity. The land becomes totally sterile.
That is just heartbreaking. The farmers are literally poisoning their own soil with the exact infrastructure that was built to save them.
It's a devastating irony.
So how do you even begin to reverse that? I mean, you can't just unbuild the Tarbella Dam.
No, you can't. You have to attack the chemistry and the hydrology simultaneously. First, you have to go in and line the canals with cement to stop that initial hemorrhaging of water.
Okay. Plug the leaks first.
Right. Then, to combat the toxic salt crust, they apply heavy doses of a mineral called gypsum.
Gypsum.
Yeah, gypsum chemically reacts with the sodium in the soil, loosening it up so that when you flush the field with clean water, the salts are driven deep down past the root zone.
Wow, so it's a chemical flush. But, I was looking at the agricultural strategies for this in our sources, and the biological fixes are just as fascinating as the chemical ones.
Oh, the eucalyptus trees.
Yes. Using eucalyptus trees as massive biological pumps is so brilliant. You plant lines of these highly aggressive, incredibly thirsty trees, and their deep root systems act like giant natural sponges.
They really do.
They actively drink the excess groundwater, naturally depressing the water table back to a survivable level.